A very good day to our lecturer, Dr. Zamri. My name is Kok Hong, matching number 285239. So I will begin the presentation for our group project for real-time programming. We are from group PowerRanger. So I will begin by presenting on for our abstract. So the title of our application is Real-Track Issue System. This project provides a comprehensive solution for real-time monitoring and also analysis of GitHub issues using a number of tech stacks, which includes Apache Kafka, Spring Boot, Docker, and also the Google Cloud Platform. The primary objective of this project is to seamlessly collect GitHub issue data, perform basic processing, and also present the meaningful insights to the user through a Telegram bot. In our project, we utilize Apache Kafka as a distributed streaming platform to enable efficient and scalable data communication between the GitHub data producer and also the consumer applications. By utilizing Kafka's messaging capabilities, real-time data changes can be captured, which will allow for prompt responses to changes in the GitHub issues. How our application works is that the producer application, which is developed using Spring Boot, will fetch and streams the GitHub issues data into Kafka topics, while the consumer application or the Telegram bot will process the incoming data and extract the relevant information for subsequent analysis, such as listing out the user and the word counts in the issues. Furthermore, the entire application is also containerized using the Docker to enhance ease of deployment and also ensure the consistency across different working environments. This method, which encapsulates the program and its dependencies into separate containers, will enable smooth deployment and also reduce the possibility of compatibility problems. Last but not least, our project adopts cloud-native practices by deploying the containerized application to the Google Cloud Platform. This will help in ensuring high availability, scalability, and also reliability of the application, and the GCP's managed services and strong networking capabilities will also streamline the deployment process and as well as providing a reliable environment for the real-time GitHub issue monitoring system.
Okay, good day, doctor. My name is Isaac and my metric number is 285626. So I would like to present about the producer application of our system. So we have two producer applications, and doctor, you can see Kafka Producer 1 and Kafka Producer 2 in our system. So in this producer application, we have some directory, and in the directory we have some class that used to run these producer applications. So we go to the entity directory first. Okay, in the entity directory we have issue class, which is used to store the data received from the GitHub issue API. And then we move to the GitHub API directory. So this directory we have four classes, and the first class is app config classes is used to define the Spring Bean for the REST template. And then for the second class is fans data controller. So this class is used help us to use to handle the HTTP requests that sent by the consumer apps. And then doctor, you can see in the line 24, which is the code that handle the fans request. And then we move to the line 26, which is the process data, and after that it will send the data to the Kafka with the code in the line 28, and then after that at the end it will return a response to the consumer or the client. So we move to the GitHub API connector class, and this class is used to connect to our fans the issue data from the GitHub issue API. Then doctor can see in the line code of the line in the line 28, which is the API URL of the GitHub that connect our Kafka producer applications with the GitHub issue processor class. Okay, this class is used to transform the JSON data to the list of the issue object and the vice versa. So method of the extract issue data list, and this method is used to convert the JSON data to the list of the issue object. Then we move to the Kafka producer directory. Okay, the first class of this directory is a Kafka producer config. So this Kafka producer config is used to manage the Kafka configuration, and the second Kafka message publisher is used to send a message to the Kafka topic. Then we move to the app runner class. Okay, this class this class to execute. This class is to be execute when the application is start. So you can see in the run method. Okay, first it will go to the line 22. It will fetch the data from the GitHub first, and then after that it will go to the line 25, process the data, and then send the data to the Kafka. So and last classes of this Kafka producer one is the Spring Boot producer applications class. So this class is the entry point for the Spring Boot project. So for the Kafka producer 2 Kafka producer application 2 are similar. The class and the entity is similar with the producer 1, but the difference is the GitHub issue repository. We have create link another GitHub issue repository. So that's all for my part, and I will pass to other group member. Thank you, doctor.
Good day, Doctor. My name is Tan Jalong, and my metric number is 2SS576. I will present about the Kafka consumer module. In this module, we have one Spring Boot and entry point called Spring Boot consumer application to start the application. And this issue class is to provide a template for us to store the issues data. And this issues service is to create a list of issues called issues and the getter and setter of it. This Kafka message listener is to provide a Kafka consumer service, which using the consume method to consume the data from two topics. First, we read the data from the topics and convert the JSON data received to the list of issue object. And we append the new issue list to the existing issue list. For this config, bot config is to add the configuration of the Telegram bot. In this case, username and token. And the bot initializer is to initialize the Telegram bot using the ini method. For this app config class is to add the Spring Bin definition of REST template. This template is to handle the HTTP request of the application. The Telegram bot class is to handle the user interaction with Telegram bot by using the onUpdateReceive method. This method will be triggered when user input a text or any input on it. So that is my part. Thank you.
Have a good day, doctor. My name is Konza. My metric number is 2S194. So next, I'll talk about the Telegram bot code. So first, the Telegram bot code have a constructor that is auto-write with several classes, including the bot config, issue service, and the REST template. So it also have a add value size that will inject the value from the properties file. So for the onUpdateReceive method, every time the consumer send a message to our Telegram bot, by default, it will display the message. Please enter with the following comments: start, fetch, display, and process. When user comment to the start comment, and it will display the welcome message, including our operation menu. So when user type for the fetch comment, we will send the HTTP GET request to two different URLs and process the response. So let's see for the process fetch request. It basically send an HTTP GET request. It capture the status, the response, and proceed based on the HTTP status code. If the status code is okay, it send a success message, and otherwise it will send an error message. So next, see about the display command. Basically, it will create an issue list, get all the data from the issue service and store inside the issue list, and it will display the issue. For the process command, it will process the data related to the issue, including display the active commenter and also display the word count. So for the display active commenter, and it will limit it by only display the 10 highest active commenter. So this method calculate and display a list of active commenter based on the provided list of issue. It count the occurrence of the username and sort them by the number of comment in the descending order. So, and also for the count username method inside it, it will take a count the occurrence of the unique username using the Java string. And next, for the last is the display will count. It will count the occurrence of the words and sort them also by the descending order, means the highest to the lowest, and also only display the top 10 highest words. So next is the last comment is clear. Is in the clear chat method, it basically clear the issue data, issue service data, and also send back the message list clear to the user. So that's all from me.
Lectures and with thanks to doctors. My name is Tanguan Shim and my matrix number is 2x7471. And today I'm going to introduce the applications of Dockers in our group projects. So in our group projects, we are using the Dockers to compile and also to package our Java programs and into a image that can allow the user to run it inside a containers, which means the user can pull the image and also run the applications, which is the Java applications, in its own computer system or also in its Docker. So for this Dockers, we have created Dockers files, and first of all, we have defined the Maven versions that we have used and also the Java versions that we have used in this Java developments. So after that, we'll copy the parent project PLM files, and also we'll copy each module of PLM and sources into the build context. So we have copied the Kafka consumer, Kafka producer 1, and also the Kafka producer 2. So after we have done copy all of the sources and also the PLM file, we have installed the parent OM and other modules. And now we can proceed to the build sections and also package all these modules. So now I'll demonstrate on how to build and also run the Dockers file. And here we go. When I click on the build Dockers files, it will run. I will build the Dockers files and create it into an image and also run it inside a container. And here is inside the containers that the Java programs are already being successfully built and also being run inside the containers. So for the images that we have already built, we have already pushed it inside the Dockers hub. So here's the images that I have already pushed in the Dockers hub. And we have using these Docker commands to push it inside the Docker hubs. So in these Docker hubs, the user can also pull the images that I just pushed. And here's the Docker repository overviews. Inside there, we have introduced our group projects applications, which is the real-time GitHub issue trackers. And also that will demonstrate how to pull and use the images. So for those users who want to pull the images, they can using this command to pull the images and run it inside its own Dockers containers, also in its machines. And that's all for me. Thank you.
Now I will show our deployed application. So to do that, you activate the Cloud Shell from the website by clicking this, and then wait for the Cloud Shell to generate. And this is the terminal. So to look at our project, so you run this command. This is our cluster. So we need to get the credential. So click on authorize. And then next is use this Kubernetes logs. Real track issue system deployment, which is our deployment. So as you can see, this is our application that we deployed in the in the cloud server. API GitHub 背回箱. That's all for my presentation. Thank you.
Good day, doctor. My name is Unyami with metric number 28524. I'm going to present about the producer 2. And the producer 2, similar to producer 1, but it's different GitHub issue report. So as usual, we have to run our Zookeeper and Kafka. So we find this file under the script and run on it. And run on it, it will automatically run and it will appear this. It means we run successful. So the next step is we have to start our producer. So we found the producer 2 files and found this Spring Boot and run for it. So when we run when you run it, it will fetch issue data from the GitHub issue API and extract the fetches JSON data into a list of issue object, and it will convert the issue list back to the JSON data, and it will send the JSON data to Kafka topic. And after we run the producer file, we have to find our Kafka consumer file and run it, and the consumer file will consume the data from the topic and convert JSON data to an issue list. So when all done run, the Telegram bot will be run. So let's look at the Telegram bot now. So this is our Telegram bot. So let us click on start. So it will give us this notice. So we click on the fetch. So after we click on the fetch, it will have data successful. So when we click the process, it will get the data from the issue and display all this. So that's all from me. I pass to the next presentation.